In the months leading up to 1944, British soldiers crept onto the heavily guarded beaches of France under the cover of darkness. They weren't there to attack. They were collecting dirt. Planners needed to test those specific sand samples just to see if the French coastline could physically support the weight of an Allied tank. Standing between the Allies and the liberation of Europe was the Atlantic Wall. This was a continuous, fortified network of coastal defenses that would cost roughly $200 billion to build today. Breaking through that solid concrete barrier was the central physical challenge of the invasion. To pull it off, the Allies gathered 16 million tons of supplies. If you loaded all of that onto a single cargo train, the cars would form a continuous line stretching from Lisbon all the way to Moscow. But for the invasion, that staggering mass of material had to be condensed onto the southern tip of England and then successfully moved across the English Channel. Overcoming geography and concrete at this scale demanded radical engineering, the creation of specific tools to solve physical problems that guns alone couldn't reach. The first problem was visibility. You cannot invisibly stage 1.5 million soldiers and mountains of steel with German reconnaissance planes actively patrolling the skies. Planners launched Operation Fortitude to misdirect German intelligence away from the target of Normandy. They invented a fictitious unit, the 1st U.S. Army Group, positioned in the east across from Pas-de-Calais, where the English Channel is narrowest. To convince German scout planes this army was real, the Allies tasked the Goodyear Rubber Company with manufacturing a fake inflatable arsenal. Soldiers positioned rubber tanks, trucks, and landing craft in open fields near the coast, allowing enemy pilots to photograph them. They even assigned General George S. Patton, the commander the Axis forces feared most, to lead this ghost army, cementing the illusion. By flooding the zone with obvious, highly visible decoys, the Allies dictated where the Germans placed their heaviest coastal defenses, securing a vital, survivable window for the real assault force. Once they reached the French coast, they faced a brutal mechanical reality. A standard Sherman tank weighs 35 tons. It sinks instantly in seawater. Furthermore, the beaches were laced with explosives and coated in slippery blue clay. The solution was a specialized series of modified vehicles, affectionately nicknamed the Funnies. To stop the tanks from sinking, engineers developed the duplex drive. They bolted a large inflatable canvas screen to the hull. This displaced the air around the vehicle, allowing it to float, while 2 rear propellers drove the massive machine forward through the waves. To deal with the explosives on the beach, they built the Sherman Crab. This variant was equipped with a rotating drum of heavy chains that beat the ground as the tank rolled forward, safely detonating hidden landmines before the infantry could step on them. By treating standard artillery as a chassis for bizarre modifications, the engineers provided the exact multi-tools required to keep the initial wave of troops moving off the deadly shoreline. But tanks burn an enormous amount of fuel. Planners calculated the invasion force would require roughly 14 million jerry cans of gasoline. Transporting that volume continuously on slow-moving surface ships would leave the supply lines completely exposed to German attacks. The answer was Pluto, the pipeline under the ocean. The British developed massive floating steel spools called conundrums. Towed by ships, these giant rotating drums slowly unwound a continuous steel pipe directly onto the seabed of the English Channel. On the British side, the pumping stations powering this underwater artery were meticulously disguised as coastal barns and ice cream shops to protect them from airborne bombing runs. Securing this hidden continuous flow of gasoline meant the mechanized units could immediately push inland without waiting for vulnerable cargo ships to dock. Still, the military had to rapidly unload delicate cargo and millions of men onto a wild, open beach with extreme tidal ranges, knowing that any established French ports would be heavily defended or destroyed by the retreating Germans. If the Allies couldn't capture a port, they decided to simply bring one with them. These were the Mulberry Harbors, prefabricated in England and towed across the ocean. To protect the temporary harbor from rough waves, crews deliberately scuttled lines of old warships and dropped massive hollow concrete blocks, called phoenixes, directly onto the seabed to create an instant artificial seawall. To move the supplies to shore, they installed floating girder bridges connecting the breakwater to the sand. Crucially, these bridges were designed to rise and fall with the extreme tides, allowing the ports to operate 24 hours a day. By manufacturing their own coastal infrastructure, the Allies bypassed the heaviest German choke points, turning an open stretch of tide-swept sand into a functioning industrial shipping hub. On D-Day, this entire apparatus of deception, floating infrastructure, and modified armor clicked into place in a concentrated 20-minute deployment window. Through that narrow opening, the logistics held. The fleet successfully pushed 7,000 different combat necessities onto the beachheads, delivering everything from surgical scissors to high-explosive grenades directly into the hands of the advancing troops. The bravery of the soldiers from 15 Allied nations was the engine of the liberation, but their foothold in Europe relied heavily on the hidden machinery carrying them to the sand. The rubber tanks, the swimming armor, and sunken harbors were calculated acts of engineering genius. They prove that overcoming impossible odds relies as much on the logistics of invention as the bravery of the assault.